Thank you, Roy. Another great presentation. Perhaps we'll make it 3 years in a row next year. Our next speaker comes to us from a small software company. No, wait. Make that a big software company. No. Well, a big software company that's part of an even bigger multinational semiconductor and solutions company. Of course, I'm referring to Intel. Here to give us an insight into Intel's software strategies, please welcome General Manager of Intel Asia Pacific R&D, Dr. Bob Liang.
Thank you. Good afternoon. Boy, the light's really here. First of all, thank you for Insight for inviting me to meet many old friends and new friends and listen to a lot of exciting talk. Today, very briefly, you have to listen to, you're going to see the third time the Intel chart in a minute. Today we'll talk a little bit about Intel. Originally the topic, apologize, supposed to be a mobile software technology, the technology. But I think you listen to Nick, right, or the data center. Nick actually told me for every 600 smartphone or 128 iPad, I don't know why 128 exactly, but we can sell one server. Right? So we can see from business perspective, the whole ecosystem, because of mobile computing, we can benefit from here. So today, actually, I'm going to talk about a couple of things. If you remember, our software, it's only the strategy, only actually 1 or 2 points. Number one, we want to make sure all the software written by our partner, our ISV partner, and ourselves run great on our IE platform. Secondly, as we move to a new area, we're going to work with you to expand the ecosystem because a new world, and we make sure ecosystem grow very healthily. We're healthy. Because we are one of the top 3 company has like the size of ecosystem or the developer system. Oh, this is the lawyer thing. Oh, I have 2 pages, boy. All right. So I think we talk about, you listen to a lot of talk, right? You listen to my friend Sam talk about a new netbook. And you talk about friend, and then Nick talk about the data center, 50 degrees C. And you talk about, I think Ken talk about the Ultrabook. But we actually did a lot of work there also because, for example, we actually work with Smart TV, and the first customer is the Zhonghua Dianxin in Taiwan, turned out to be, right? And we later worked with French television free, then we with the Italy telephone and television set-top boxes. But you listen to Helen's talk, actually it's interesting. She mentioned that the biggest consumption market for PC, actually any IT equipment will be in China, right? So it's very interesting. And but remember 30 years ago, Microsoft and us starting working with other people, we building a computing industry. Actually, the Taiwan industry built the PC industry. So we're very close. The biggest market in Taiwan and 2 hours away, in Taipei, right? I love Zihang, right? 2 hours, Songshan, we got here. So this actually is a very good opportunity to grow the next market, those kind of stuff. So before we go further, we actually have a product line powered by Xeon in the server side, Core i3, i5, I said we just announced the i7 2700K, right? They have the Atom. Now, we listen to a lot of the CPU, GPU, those kind of stuff. I have a friend of mine, the CMU professor, John Shant, he used to be professor, and he told me, Bob, there's no such thing as general purpose CPU because x86 8086 is just a PC, it's just a PC processor built for Microsoft spreadsheet. So we should call the spreadsheet processor, SPU, right? So in some way, you can see the CPU. For the cloud, we have a CPU, cloud processor unit. Client, CPU, client processor unit, going to be changed. The reason I mention it, we are very market-driven, see what happened. Because you go through history, you see from the Pentium 4, Pentium 1, Pentium 2, Pentium 3, Pentium 4 days, we spend a lot of time on performance, right? And the Centrino 2003 comes, is the power. right? You can see a lot of supporting our customer engagement also that way. So if you are in the IDF last month in San Francisco, Justin Ratner, our CTO, mentioned about very small core, extremely powerful, extremely life-saving in the lab is a processor, right? So the thing going to change, the process unit going to change, but we going to solving customer problem, right? So I think all of us here, how do we do that? How do we see new challenges, right? Something there. So with this, there's two pieces, right? Because with that, I say one more thing. Because China is a huge market, we putting in Taiwan, and I think has a lot of the platforms, PC being built here, designing here. We actually starting building up our platform team in Shanghai. So I've been in Shanghai 4 years, started a software group, but right now, every single group, we have a platform team there. For example, server team, we have a 200 people team building server, doing a lot of different kind of work, right? Not only for power saving thing, with our power saving rack, doing all those kind of work, prototype work, working with the partner in Taiwan, right? Every single one, right? So hopefully, I think this is the way we're going to do. Our size grew about 3 times since last 4 years, right? And start going. Now, which is the new charts, but I'm going to take a different angle. I think there's a different interesting thing about this. High K, that we do the high K, which is the mass production, and then do the tri-gate, right? The tri-gate for this year actually pretty neat. Basically, it was 3D. You're going through that, you do this. What I'm trying to say is, there's a different trend here. When you do the high K, about 2007, it's about 10 years, more than 10 years, the research, right? A lot of physics, chemistry, those things, we take a leadership. But many of them are from, I think, scientists from China, Taiwan, Hong Kong, right? So the thing is, and go back to here. So it used to be the way we draw the talent to come to US to work on this product for worldwide product. But as we know the talent going through the worldwide, so as we're going to see later, a lot of our tools, all the platform stuff are being started doing, going through actually different part, right? I'm going to talk about, keep that in mind. I'm going to tell you some of the stuff we're doing actually will take the, like the local talent and we'll start building it. Now, the other one is the software. So in order to, we talk about the first picture is a platform. Second picture is the technology, silicon technology. But then there's a little bit thing there, right? Once in order to build a great product, we need operating system, application, and actually we need to expand our ecosystem. As you know, the hardware getting cheaper and cheaper, right? The chip. When I joined Intel in 1997, average selling price for Pentium 2, if you remember, $600, right? I don't think you can go, I think you can, $600, you can buy multiple PC right now today, right? So I think we need to work together to expand the usage model, those kind of stuff. And also think that requirement change. Used to be very simple, just performance, then the power, then now by coming the security, then is the usage model more complicated. So I think we need to, the product cycle shorter. So that's why we need to get better. So I'm not going to cover a detailed thing. Intel actually have 30 years of software product in Intel. But I'm going to go through a couple of things which would be called the market requirement. Actually, when the visual computing, we actually purchased and worked with some company because in the game, early stages, like Havoc is a company we bought in England, the Ireland, and which did the physics for the games, right? We're using not just our stuff, and more our competition or our other platform, which is the physics company, right? Because we see that during that time, still the performance, just the graphic framework is not enough. We need to do the physics, those kind of stuff. Now, the other one is, remember when 2003, the Centrino come, which we stopped doing the very expensive, very huge core, like Pentium 4. We're still doing it, but I think it's because the power is something, we start go to multi-core. But then, how do you program multi-core? Right? This will take a long process, right? Because it's not just everyone can write the core, right? You have a different kind of stuff. So we spend a lot of time building this. But in building this, you can see here, in building of this, we purchased some company, we grow up some company, we also invest in, I think, in the research. In, for example, go back in this country, Microsoft and I think us jointly funded Berkeley and Illinois, right? And I think multi-billion dollars to do the research on how to make the programming easier, multi-programming easier. Now, this is just upstream. Later I'm going to talk about the downstream, right? How do you get the result? You get the product. How do you proliferate it, right? So those kind of things, we spend time, which probably not many people know about this. Now, then I think since we want to move in the Wind River, in the embedded system, and the big embedded system actually including very huge one, like Huawei, Cisco, I think the switch, they are part of the embedded system. So we start understand which project Wind River, understand the requirement. Right, the whole idea is the following. We have to understand, so latest one is McAfee, which is a huge requirement. McAfee, the size is bigger than the Origin SSG and all everything combined. Because the security is very important, but we need to know McAfee actually work with the enterprise. And we need to know what right feature put in there. Because security is a very, very complicated issue. Different country, different standard, right? And you have to go through all this thing in enterprise. So we've been working with our partner, right? You listen to Tony, Microsoft, the fantastic talk about his TPM, those kind of stuff. So we also had to go through the application level, go down, and go to the thing there. So we've been working very closely with McAfee, the Harvard team, and Microsoft, for many, many years, and see what is the right feature to put in the hardware, what right feature to put in the firmware, what right feature to put in the software, what can to do. Because some of them, the complication is something you cannot, there are several products, we cannot put in the hardware feature because like China and Russia don't disallow you to get in there. You have to use a different screw, right? So this kind of thing we have to go through, and so that's only through people close to customer we understand. So you can see the gets out of it, our software, not just optimization, building a tool, we have to understand the requirement. Okay, so I think, listen to the talk, I learned a lot, right? Because of every distinguished speaker saying, user experience is the key. But so my talk is going to be, I'm not a sales guy, I cannot tell you I know everything. Actually, I know very little about this, right? I cannot clone Steve Jobs, right? So I think those kind of stuff. So this is actually a very tough question, right? So what we want to do is create a platform for others to innovate, right? Together. So we are trying to find working with a different. For example, Intel ran a creator project, right? Working with all the media people, those kind of people, understand what the trend is, right? So listen to the people like 1 year, 2-year-old kid, right? So they're using the touch thing, right? So those kind of stuff we need to learn just like everybody else. But this is something we see how we can do it. Now, so the software, so okay. Now, the first thing I'm going to talk about, the thing is the operating system. So we've got 3 pieces. Things just like Microsoft cannot tell anything in the process of work. So I'm using the borrowed old Windows 7 chart, but basically think I'm going to cover this. Basically, we've been working with Microsoft very closely. We have an army of people work with Microsoft, right? So worldwide, on the drivers, support the Microsoft Windows. We bring the platform, especially heavily all supporting the work being done I think in Taiwan, right? So we've been working with them for 30 years. And my first job in Intel in 1997 is working the D3D driver, which actually the DX1, the DX2, whatever they call them, you name it, right? So actually it's interesting. I learned 2 different big elephants, different culture to work together, quite difficult. But for now, for 30 years, we know how to work with each other now. So I think this is actually one of the major, actually you heard Ken said, this is the major focus for our, the next product. Now the other one is the Android. Right. So the Android, I think we actually shipped the first TV and Android TV because with the team, we go to work with them. In the IDF, we finally reached agreement with Google. We are doing the both optimize all their stuff on our every single platform. So we have people in worldwide everywhere working on this platform, trying to make it actually as successful as possible. Now, interesting enough is we do have some the advantage for developer, because you think about this, the Android is using probably for any device using Android going to be using an Atom. Now, but you can using the PC. The Atom in some sense is a subset of PC. Now we can using, for example, in the lab was not publicized. I don't know where to publicize it now. We can using the VM, the technology, right? So then we can build a simulator on top of that, right? So we can run the simulator 10 times faster than the software simulator using the actual x86 instruction. So those kind of things we can do, right? So you see, my point is, in order to helping the simple thing, we need to report in simulator, debugger, all those things, right? So all those natural, those NDK, SDK, those kind of things, we will spend army of doing it to make sure it's successful. So a lot of work is probably behind, but I think it's underneath, but actually most of the people are working on this part. Now, ecosystem application, right? Some ecosystem. So we do a lot of development tools, right? We have a 90 available product. We have the dollar product, tool, library, those things. Which I can talk about the tool in a minute. Remember earlier I said about Intel is selling the product in 203 countries in the world. But also, I think we had to take advantage of the countries with the talent. For example, we have a library called Math Kernel Library, right, which is being developed in Russia. Then you say, why in Russia? Right, so it's interesting, the historical reason, because I'm managing the Russia team for a while. Because about 15 years ago, Soviet Union dissolved, right? Then we worry about those people be hired because these are engineers living in the barbed wire city who build bombs and build missiles, right, for the Soviet government. And they worry about those people will be moved to like some terrorist country. So I think we've been hiring those people, like Boeing hired those people, we hired those people. These people are very, very talented for writing library because embargo, US don't allow any computing equipment selling to Russia, so they can, it's amazing, they can writing a program for shooting the rocket using PC, writing x86 assembly code, right? So it's really fantastic. So we have a team of them, and so we have a huge team writing a math kernel library. So for example, even in the multi-core, we parallelizing write a library for you rather than you writing yourself. The thing is, how do you validate, right? How do you know the code is okay? So that's where the ecosystem part come from, right? We've been working, myself, when in the US, we working with the financial industry, we work with different vertical industry, we work with the entertainment industry, right? Get their workflow, understand how they do, then adjust our library, right? So the library team is actually one of the teams we've been working on. So these are the stuff behind the scene, but I think we've been tested, going through, there's the tools, something there. There's about 90 of them. There's a V team, those kind of stuff. Now in the parallel, we put out a lot of cluster tool, parallel studio tool, which is probably mentioned later, and we provide a lot of training. And we do have a development engagement and development program in each geo, right? So we have different relation. When we talk about, I'm going to use in China the example later, how to work with the ISV ecosystem. So the thing is, we are building this software, even the compiler technology, and it's because we support the new processor, right? So only us can do this. Our job, as I say clearly, is to make sure other people or any software run great or make sure it's on our platform. But the things change a little bit, right? Remember Nick mentioned the DCM. Actually, the data center management team, development team is in Shanghai because we later find out the software, the power is very important. The node manager is the side we talk about, but you have to be a global manager, data center manager program to managing it. So we've been writing out the program, going through, and we've been tested in several data center, right, to get the stuff, just like anything. So a lot of software, middleware we wrote was in that way. We get a real customer. Actually, sometimes we work with our name brand OEM together, getting there. Now, so this one I'm going to talk about a little bit, something. So we covered the other part, right, something. I'm going to talk about two things, academic community and the Intel Software Network. Remember I talked about the parallel computing. We bought a company, right? We bought several companies. Then we're building a tool, so a parallel studio, right? So then we validated using it. But how do you teach them, right? So each country, we have a very thorough academic program. So I can tell you about what we did in China. for 6 years now, we've been running a multi-core programming program, right? For 6 years now with the university, actually working through the Chinese Ministry of Education, right? And we work with the leading professor, right, Zheng Weiming, those people. We compose the curriculum, not just the book, the curriculum, how to do the parallel programming, all the professor. For 6 years, the way we do, the first year we do 5 schools, second year do 10, 30 to 37, then go through. And we run a parallel programming contest every year, right, for 3 years now, right? So we get so half the people speak Chinese, like contests. So I think for last year, about top 10 people, 5 of them are university people, students, and 5 of them are actually working at a different industry, like Microsoft, IBM. I think there's a software programmer. So we actually test them, write down, give it 2 hours, write the program, compile them, and test it right out, so on and so forth. About 9,000 they participate, we filter. So these kind of thing we do. So we do a lot of stuff. For example, for embedded system, we work with the lab, so on and so forth, the university. Now, I think why I'm doing this, because we find out it's very difficult because I talked to Jeremy, and I think that something about, we have a shortage of the EFI programmer, right? It's very difficult because the kids like to write web program, right? To write in the internet, that kind of browser program, Java program, then you can join a startup like Groupon does, right? I think in China, so very difficult to get people there. So we running 3 years now, we run like a UEFI workshop, right? Dong Wei actually was give a talk last year, right? Something, I think this year, last year, the next speaker. So I think we try to get because also we trying to find thinking about it, working with the university, and also we trying to understand where the new usage model from there, because our collaboration is not a CS department, not EE department, it's Jiao Tong University, which is the information security college, right? To understand how do you have a new message, those kinds of things. Also, hopefully we can supply of the students coming to this way, right? So this actually was the part about getting the future programmer on our processor. So we spend a lot of time on this one. Now, as we move to embedded or those kind of different markets, this is about thousands, like 8,000 of customers we counted in there. Each one the volume down there. We cannot support them. How do we do this? So we put up a Intel software network, right? So get necessary information together. They become a different block. So I didn't have the chart. So I have a lot of different discussion group, multi-core group, embedded. So I think it'll be helpful to generate, to promote the stuff. So a lot of stuff is trying to bring up the level of the people who can help build up the ecosystem, those kind of stuff. But these are the skill, right? It's not the thing. It's not there's still a way to the user experience, right? So it's kind of do. So this is where you require, I think, some more additional work, which I don't know how to do. Let's see. Okay, so we have probably, SSI, we have one of the top 3 developer community there, something there. Now, I think next few charts are going to cover a thing here. So I'm not going to detail. The basic thing we say we have roughly 3 families: server family, client, and Atom for all the other devices. How does the software support? What are the tools? Right. This is going to be eye chart, but I'm not going to detail. For example, these are the 2 roadmap. Right. So high performance computing enterprise, we go through here. Now there's all this other things probably not there because, for example, in Russia, besides mass kernel library, they're very strong in high performance computing. Actually, Russia is a huge, I think they're doing that. So what we do is we have a different kind of the package or whatever going here as application. We have a cluster, so these are high end, and many cores. So these are the stuff I think we're doing support, so the hardware support, right? So focusing on this one here, and we've been promoting and using that. So a lot of the other library, right? So it's a small mass kernel library, building block, those kind of stuff, which support Windows, Linux, those kind of things, Fortran. And for client, we support all those, right? All the things, similar thing. So this is very interesting. 2 years ago, when we do the roadshow in China, right? So everything we can talk about, example, is a server. But now I think for here, there's a lot of people using the client because of course all the dual core, I think a full core laptop, people starting to take advantage of it, right? So we start have to running a lot of other stuff. So these are the all the I think the atom device, those kind of the things. So this is a beginning. We guess as the time goes along, we're going to have a lot more. Right. So this is my last chart on this thing here. So remember, for each geo, you have to remember, not even though we programming solely English, but not necessarily everywhere English is the native language you speak, mother tongue. So I think in China, this is actually very interesting. So I just talk about China. We do the similar thing to the other geo, but I think probably different languages. I think some of them. But I think this is something that, what here? Now remember, we're doing the thing for the university, but this is the future. How about the now, right? The China has different, has a software park. So we have representing software park. We work with third party, right? We generate all the picture, everything into that particular part, right? Something there. So this is just a fracture. We build 30 courses, and usually what we did, we connect the university professor and the software park material. Okay, so there's a finish, something. Okay, I think we sort of we finished the talk is thinking we have in the environment now, we have a lot of devices, we're going to create a new world. But there's one thing missing, right? What's missing is the following, which is the EFI, right? Which is a good introduction to my next speaker, following speaker. Because I hope our future, because actually the really interesting thing is, the relationship we built with the inside was started 10 years ago, from a good working relationship from the EFI. And I think that with that, we can see, we hopefully, we just say, many Harvard courses with a common firmware foundation. Otherwise, it get out of control. With that, thank you very much.